If you're like me, you probably rely on public transportation a whole lot. And unless you've been living under a rock for the past year, you probably also understand why public transportation is a lot riskier nowadays during the pandemic. So I thought it'd be a cool idea to build a little tech demo that showcases Eclipse Paho and Eclipse Mosquitto, while also working around the idea of trying to make public transportation a little bit safer. I'll show you how I ended up building a bus station pay terminal that detects your temperature and rejects you from entering the station if you have a fever. Alright, so let's get started. The electronic components that I used for this project are a Raspberry Pi 3 Model B+, 7-inch touchscreen, an RC522 RFID reader/writer, an AMG 8833 IR thermal sensor, power supply for the Pi, HDMI cable, and a USB to micro USB cable, and also assorted jumper wires to connect our sensors to the board. I also decided to design and 3D print a little holder for all these electrical components, just to keep everything nice and organized and pretty looking. I'll leave the files up on the GitHub if you want to download it and you have access to a 3D printer. Next, using a soldering iron set to 350 degrees Celsius, I set some M3 brass threaded inserts into the holes of both the front display mount and the RFID sensor mount. This is just so that I can repeatedly screw and unscrew without having to worry about potentially stripping some threads. With that out of the way, we can go ahead and fasten our thermal sensor to the top of the display mount using M2 nuts and screws. And we'll go ahead and do the exact same with the Pi in the back mount. Now we can go ahead and plug in our HDMI and USB cable from the screen to the Pi. And then we can go ahead and wire our sensors to the Raspberry Pi itself. If you want to know exactly where each wire goes from which pin, check out the GitHub repo for more details. And with that, the hardware is finally complete. So this is a look at our bus server code. So while the other script is running on our Raspberry Pi, this I'm going to have running on my Windows laptop. You'll see I've also imported Paho over here, and I've also defined the MQTT broker's IP address over here. The difference is while the fever detector is acting as a publisher, this server code is acting as a subscriber, and it's subscribed to the temperature fever transaction topics from earlier. So if you're not familiar with how MQTT works, how it works is there's clients that can act as a publisher or a subscriber or both, and there's a centralized broker which makes sure that messages published to said topics are being routed to the proper clients that are subscribed to said topics. So because I'm interested in the temperature, fever, and transaction data being received by our bus fever detector, I'm subscribed to said topics. And this onMessage method is just to make sure that the messages received is being printed out onto my terminal. So if I run this script, you'll know that it's connected successfully when it says connected with result code 0. And you'll see it's receiving my temperature data and transaction data and publishing it to the terminal. So this is our bus fever detector script. You'll notice over here I imported Paho. This is because I'm using Paho to implement this as a MQTT client. And over here at the top you'll see I've also defined the MQTT broker's IP address. If you want to run this code for yourself, you're going to want to change this to match the IP address of wherever you have your Mosquitto broker running. And it's important to note that this script you need to make sure is running on your Raspberry Pi with the sensor set up. So if you scroll down over here to take a look at this part of the code, you'll notice that whenever the sensor is receiving temperature data, it's being published to the MQTT topic temperature. And whenever there's a fever detected, it's publishing to the fever topic. And whenever a transaction is completed, it's being published to the transaction topic. So if we hit run, current script, you'll see it pop up. And here is our demo. And you can kind of just see me waving at the heat map. All right, so Let me show off the demo here with a little bit of commentary. You'll notice in the top left there's a heat map which shows exactly what the thermal sensor is detecting. I put it there just for the demo, just for demo purposes, because I think it does look cool and it is a way to verify whether or not the heat sensor is working. So you can see I'm a little visible there. It's asking me to please move closer to the sensor because I'm obviously not close enough. So one problem here is that I have to kind of bend over just to get it to read me, and then the arrow changes to down to indicate please tap your card below. I'm going to tap my key fob. It's going to say insufficient funds. That's because I'm a broke college student, so my card has no money on it. I have this card which does have money on it, luckily, and we'll try it again. Please tap your card below. Thank you. New balance. So that's it working, obviously. But the interesting part is whether or not it can detect hot temperatures. So next, I grabbed this. It's a spool of filament, warm from the oven. I left it in there to dehydrate a little bit. So it's obviously a little bit warm. It's gonna be warmer than a fever on a human, but I just wanna use it to demonstrate that once it detects a hot temperature, it's kind of sending out these warnings. This is obviously a pretty basic demo, but I think it's a fairly relevant and interesting use case. And it serves as a pretty good introduction to Eclipse Mosquitto and Eclipse Paho, if you ever want to incorporate that into your future IoT projects. I'm hoping to build more tech demos like this, so if you're interested in seeing more, consider subscribing. Thanks for watching.